Okay. Wishing a very good afternoon to all of
Okay.
you. First of all, let me welcome you all for today's session on machine learning for beginners. I must say that this session will be an absolute guide on machine learning, and I'm pretty sure that at the end of today's session, you will be able to clarify all your doubts. So, without further ado, let me introduce the speaker for today's session. He is currently a software engineer at 99X Technologies. Not only that, he is one of our own beloved seniors from batch 15. Not to boast about himself, he is friendly indeed with anyone and who is always willing to help his juniors at any time. So please welcome our speaker, Mr. Nishan Vikramaratne. Over to you, Nishanaya.
Okay. Thank you, guys. Thank you for that introduction. And the main reason, or rather, main motivation behind the series is get you guys up to date with machine learning and related technologies. Because actually, I feel like that the machine learning module actually comes under level 4, and there's another module called data mining, uh, which is also comes under level 4, but we were in the faculty, it was there in level 3, but now it's, I guess, moved to level 4 as I have heard. So waiting that long to get to know about machine learning, I guess, is not a very um, it is not a very favorable way for you guys, because you might participate in various competitions, and then you might come across other personal projects that you guys are working on, and you are also trying to preparing for this uh, internship as well. So then in there also, if you guys have some level of an experience regarding machine learning, it will be helpful. So that is why we are trying to do this session, and this is going to be, as the title says, machine learning for complete beginners. So let me share the screen first, and then we will move on. If you guys have any questions, you can ask them right away, or if you have time, you can wait until the end. Right? I'm trying to explain it a very simple manner, using both Sinhala and English. Tamil people don't hate me. But if you guys, even Tamil guys, have any questions, you can ask me as well. Right. Anyway, so we'll start. I will share the screen. Yep, the screen. I hope you can see it. Can you guys verify whether it is you
Yes,
guys?
Arya.
Yeah.
Yeah.
Okay. All right. Nice. Now we will start then. Give me 2 seconds. Yeah. Okay. Okay. We'll start. Now, when it comes to so this is actually, as I said earlier, machine learning for the complete beginners. So in this session, I'm going to basically introduce you guys to the machine learning concepts that we talk in the industry or in the data science field, and then I will introduce you to a few of machine learning models. And when it comes to machine learning models, you guys may not know what are models, machine learning models, and then I will explain that as well, and then we will do some demos as well, so you guys understand the basic ML concepts. So why do we need machine learning? That is mainly because we want to convert data into decisions, and then again those decisions can be converted into actions as well. So mainly for things like decision automation and decision support, we use machine learning. So at a glance, you might not understand how we can convert data into machine learning, into actions. But basically, what you have to understand is that we are trying to transform our data into an intelligent action, right? That is it. So this machine learning actually comes under artificial intelligence. Um, so artificial intelligence is like an umbrella term. Subfields. So AI is, as I said, it is a very vast field. Like you cannot cover artificial intelligence in a session like this. It actually includes various kinds of algorithms, mathematics, statistics, and other, very work intensive problems. But machine learning can be introduced to anybody without going deep into those mathematics and statistics, because there are ways that you can learn machine learning uh, without using those. Actually these days, even grade 8 students are doing machine learning, so you guys should too. So this that is what I'm trying to say, because even if you feel like this is very hard to understand, it's okay. You can just take a pause and then revisit the slides, or rather you have many more resources on the web as well, so you can go through them as well and then try to understand these things, because this is going to be the future. Now, machine learning algorithms, models, these kind of things must be confusing for you. So let me try to explain it a very simple manner. You already know these equations like y equals mx plus c and y equals mx. Likewise, these kind of simple equations, right? So machine learning is actually the same thing, but it is very complex. So what at the end of the day, what we are trying to do is get a value for this y, and if let me get this laser point, yeah. So at the end of the day, what we are trying to do is get this y. It could be a simple equation like y equals mx, or it could be some kind of a complex equation like this. Right? Again, y සමාන mx වගේ සමීකරණයක් කියලා හිතන්න මේ machine learning model එකක් කියන්නේ. එතකොට y කියන value එක අපි ගන්න තමයි හදන්නේ x වලට ආදේශ කරලා මොනවා හරි values ටික. හරි. ඒ කියන්නේ මේ දැන් අපි සරලම පළවෙනි case එක ගත්තොත්, if we take the first case, let's assume this is y equals mx, m is w1 and x is x1. So first of all, we have kind of a data for y, and then we have set of data for x. x වලටයි y වලටයි data ටිකක් අපිට දුන්නොත් අපිට w1 හොයන්න පුළුවන් අනුක්‍රමණය, right? If we have set of x values and then if we have set of y values, we can uh, approximate the value of w, right? Now after you found the value of w, then only value you need is x to get the value for y, right? I hope you understood. ඒ කියන්නේ අනුක්‍රමණය හොයාගත්තට පස්සේ අපිට x value එකක් දුන්නොත්, ඕනෑම x value එකක් ලෝකේ තියෙන අනුක්‍රමණය හොයාගත්තා නම්, අර කලින් අපි ගාව තිබුණ data පාවිච්චි කරලා අනුක්‍රමණය හොයාගෙන, ඊට පස්සේ අපි කලින් නොදකපු data point එකක් x වගේ data point එකක් දුන්නොත් අපිට y එක හොයන්න පුළුවන්. That is the basic fundamental principle behind the machine learning. If you can get a value for w using previous data, and then after you approximate a value for w, any other x value should give you the result of y for that specific x value, right? But usually these machine learning models are not y equals mx, they are very complex, and there are many different ways to build these models. But what happens inside this machine learning problems is this: you train a model using previous data, and then you can get a new prediction or a forecast based on those data, right? That is what machine learning is. Now, there are very, as I said earlier, there are many kind of machine learning models. As an example, so here you can see this is machine learning algorithm called the decision tree. What happens is it is trying to predict whether a person is a Xbox One customer or not an Xbox One customer, right? But it comes to that decision based on different several conditions. As an example, if the first condition is age less than 30. If yes, is income less than $50K? If yes or no, he or she could be a decision, Xbox One customer. Based on different conditions, it comes to an end result. So that is an algorithm, right? This is not a model. So this algorithm can be converted into a model. After you convert it, it actually comes like a if else conditions. These are very similar for you guys. You know what is if else. So based on the algorithm, you create the model. This is actually happening, like you don't have to do this by hand. There are very easy ways to do this these days. So don't worry, you don't have to write if else conditions when it comes to machine learning algorithms. So you don't have to write complex algorithms or complex equations. It is very easy, but without knowing these things, you cannot do those. That is why I'm explaining. This is similar to the programming in command line interface before doing web applications, right? So yes, so our model is if else conditions converted, right? And there are different kinds of machine learning as well: supervised machine learning, unsupervised machine learning, and reinforcement machine learning. So the most beginner friendly machine learning type of out of these things is the supervised machine learning, because as I mentioned, it involves a data set, and then you train data, and then you predict a value. Uh, I will explain to you what are the differences of supervised, unsupervised, and reinforcement. But this is not the only three types that we have. There are multiple types, like semi-supervised kind of things are there as well. But try to get a basic understand. There are multiple types of machine learning, and these types actually converted into different kind of problems. If you look at here, you can see this supervised machine learning can be applied into classification problems, regression problems like forecasting, predictions, process optimizations, like so. And if you're using unsupervised learnings, you can do meaningful compression, big data visualizations, feature elicitation, likewise. It's kind of, it is not really advanced, right? But you have to understand what is supervised learning before moving on to unsupervised and then moving on to reinforcement. That is why I chose supervised learning to start. Otherwise, you will be confused in the process. Now, I will explain what is forecasting, what is predictions, like so, because those are the most common terms that you hear, right? You don't hear these things, right? Customer segmentation. ඒ වගේ ඔයගොල්ලෝ අහලා නැහැ. මේ වගේ හැමතැනම එහෙනම් forecast, weather forecast කියනවා. ඊට පස්සේ prediction කියනවා. classification කියනවා. එහෙම ඇහිලා තියෙනවනේ. ඒ නිසා අපි ඒ ගැන පොඩ්ඩක් අවධානය යොමු කරලා බලමු. Forecasting is a process of making predictions based on past and present data. This actually involves a date. We call them as time series. Time series එකක් forecast කරන තමයි අපි forecasting use කරන්නේ. Meaning that variables that change with time, like stock values or the value of the dollar or the temperature, like so there are variables, there are some variables that change over time, right? If you want to change a future value based on the time, then you should use forecasting. ඒ කියන්නේ අනාගතයේ දවසක මොකක් හරි value එකක වෙනස decide කරන්න ඕන නම් forecast කියන එක තමයි use කරන්නේ. right. ඒක තමයි forecasting. එතකොට ඔයගොල්ලෝ දැකලා ඇති stock market එක predict කරන්න මේ වගේ graph ඔයගොල්ලෝ දැකලා ඇති. So this is daily climate analysis for the city of New Delhi. So you can see we have past data until 2017, which can be seen in the black dots. So based on those black dots or other past data, we calculate what could be the future temperature of New Delhi. You can see it is increasing, which is not a very good thing, and not something to be surprised as well, because මේ වෙන දේවල් එක්ක එක පුදුම වෙන්න දෙයක් නෙමෙයි, right? ඒ වුණාට ඒක වැඩි වෙනවා. 22 දැන් අපි 21 ඉන්නේ, 22 යුද්ධි. හරි. තව ඉතින් ඉස්සරහට මේක අඩු වෙන්නේ නැහැ. ඉතින් මේ ට්‍රෙන්ඩ් එකනේ මේකේ බලන්නේ. එතකොට සරලවම කියනවා නම් මේ ට්‍රෙන්ඩ් එකක් ඇනලිසිස් කරන එක තමයි කරන්නේ. ඒ කියන්නේ ප්‍රවණතාවයක්. හරි. මේක මෙහෙම වැඩි වෙන එක වෙලා තියෙන මේ අවුරුදු 4ෙම. ඒ නිසා ඉස්සරහටත් එහෙම වෙන්න පුළුවන්. එතකොට ඒ වගේ තමයි ෆෝකාස්ට් එකක් කියන්නේ. Before moving on to the other classifications and predictions, you have to know this set of variables, types of variables. There are variable type such as categorical variables, binary variables, and continuous variables. These things you know if you have studied statistics. Statistics ඉගෙනගෙන තියෙනවා නම් දැනගෙන දන්නවා. දන්න ඇති අයට තමයි කියන්නේ. හරි. Categorical variable, as an example, it is like to identify distinct groups like hair color. You can divide people into different groups based on categorical variables, hair color, and then you can have something like male or female. Sorry, when it comes to male or female, it is only two, right? Categorical not dekai, male or female. So in that case, that is called a binary variable. And continuous variables are mostly involved with numbers like age, temperature, like so, right? So you don't have to go deep into these variables. Just remember that there are different types of variables. But then again, you have to understand, as I mentioned earlier, machine learning models are mathematical models, right? So to deal with mathematical models, you have to have numerical data. මේ mathematical models නේ. ඒ කියන්නේ statistics එක්ක සම්බන්ධයක් තියෙනවානේ. එතකොට ඒ නිසා values ඕනේ, integer හරි float හරි මොනවා හරි. දැන් මේ වගේ variables, categorical variables, ඒ කියන්නේ වචන තියෙන ඒවා blonde, red, brown මේවා integer නෙමෙයි. එතකොට you can't use those. Categorical variables, if that doesn't have a numerical representation, you cannot use those into machine learning models. So that doesn't mean you don't have to use it. You can use them, but first of all, you have to convert them into numerical variables. Like you can convert, as an example here, you can convert blonde to 1, and then red to 2, brown to 3, and black to 4. මේවට අංක හතරක් දුන්නොත් 1 2 3 4 කියලා. blonde කියන්නේ 1යි එහෙම කියලා. එතකොට එහෙම කරොත් හරි. හැබැයි එතකොටත් again what you have to understand is, as I said earlier, these comes under these statistics and mathematics. So since black having the highest number, which is 4, and blonde having the lowest number, which is 1, the mathematical models tend to differentiate between blonde and black based on the value itself. So you have to assign a fair value. ඒ කියන්නේ මේකට 1 දීලා 2 3 4 කියලා මේ තරම් නම් කරොත් black කියන එකට 4 ඇවිල්ලා, ඒ කියන්නේ ඒක 4යි කියන්නේ important වැඩි වගේනේ. නැත්තම් සමහර machine learning වලට අඩුම වගේ. ඒ කියන්නේ 1 කියන එක important වැඩි වගේනේ පළවෙනියා වගේ. එතකොට අර value 4ට සමාන value එකක් assign වෙන්නේ නැති වෙලා යනවා. හරි. ඒ කියන්නේ machine learning model එක differentiate කරන්න බලනවා. මේක වැඩි importance එකක් තියෙනවා 1 තියෙන ඒවාට. වැඩි ඊට පස්සේ වැඩිම නම්බර් ලොකු නම්බර් එකක් 4 වගේ තියෙන එකකට අඩු ඉම්පෝටන්ස් එකක් ඇති කියලා ඩිෆරන්ෂিয়েට් කරන්න බලනවා. හරි. මම මේ very basic කියන්නේ හරි. එතකොට ඒක නවත්තන්න නම් මේවට සාධාරණ values 4ක් assign වෙනවා. හරි. අපි ඒක කරන විදිහත් බලමු. වෙලා තියෙනවා නම් ඉතින් වෙලා තියෙනවා. ඕගොල්ලන්ට වෙලා තියෙනවා නම් අපි ඒක බලමු. Right. Now we comes on to what is prediction and classification. So prediction is about predicting a missing unknown element, usually a continuous variable in a data set. So you can use different kinds of models based on what you are trying to solve. So as an example, you can see in this diagram, these are the data and the algorithm is this line where you specify where to, I mean, which value, where this value lies. ඒ කියන්නේ දැන් මේ data set එක දිහා බලලා ඔයා මෙහෙම line එකක් ඇන්දොත් ඔයාට කියන්න පුළුවන් ඊළඟට හම්බෙන unknown value එකක් මේ line එක උඩ තියෙන්න පුළුවන්. මේ line එක කියන්නේ සාපේක්ෂව ටිකක් එහෙම වගේ එකක් නේ y සමානයි mx වගේ සමීකරණයක් නේ මේකට තියෙන්නේ. එතකොට ඔයා ඒක ඇඳගත්තොත් ඔයාට පුළුවන් ඊළඟට හම්බෙන්න දන්නේ නැති value එකක් කොහෙද තියෙන්නේ කියලා මේ line එක උඩ කොහේ හරි තියෙන්න ඕන කියලා අපිට කියන්න පුළුවන් සරලව, right? So this is like a prediction. Basically what we have to understand is it is predicting a value, right? It could be a stock market value, it could be a person's height, it could be an age, like so. Doesn't have to be, you know, that kind of examples. You can actually predict many things. When it comes to image classification as well, what we use is this classification, but it in under the hood that is also using a prediction. මේ ඔගොල්ලෝ මේ වචන අහලා තියෙන prediction classification. ඇත්තටම prediction තමයි තියෙන්නේ. classification කියන්නේත් එක්තරා විදිහක prediction. ඒතකොට classification වලදී categorical variable එකක් predict කරන එක තමයි කරන්නේ. හරි. ඒ වචන වල තේරුම් හරියට දැනගන්න. ඒක මොකද නැත්තම් කන්ෆියුස් වෙයි කවුරු හරි මේක මෙහෙම වැරදි කියද්දි ඒක එහෙම නෙමෙයි මේක තමයි හරි කියන්න ඔයගලන්ට නොලෙජ් එකක් තියෙන්න ඕනේ මේ data මේ වලදී නෙමෙයි කොහෙදිත් හරිද right okay so now we comes under the topic talk about label data don't worry this is not going to be a slide show නිදිමත එනවා නම් මේ නිදියන්න එපා මේක දිගටම slide දිගට යන්නේ හරි label data like this is as you can see it is very easy to understand if you have a data set and if you have a column saying these data are dog and these data are cats and so that doesn't have to be that attribute you can have another attribute as well like in this case it is weight so in a labeled data you will have the weight of the uh, dog and the weight of the cats. So if you have like so a label that says that explains what is this data point, then we call them as labeled data. කියන්නේ data point එකක් ගත්තොත් එහෙම මේ data point එකේ ඉන්නේ බල්ලෙක්. අනිත් එකේ ඉන්නේ පූසෙක් කියලා ඊතල ගහලා නම් කරනවා කියලා හිතන්න. ඒකට එහෙම නම් කරලා තියෙනවා නම් ඒක labeled data. නැත්තම් unlabeled data කියලා කියනවා. හරි. එච්චරයි එතන දැනගන්න ඕනේ. Right. So අපි real world example එකට එමු. So this is what we're trying to do here is to predict the heart attack possibility. Now you can tables like this when it comes to supervised learning. So this is our label, which is the target variable. ඒ කියන්නේ මේ සම්පූර්ණ row එකේම තියෙන එක්කෙනාට heart attack එකක් තියෙනවා කියන එක තමයි එක කියලා කියන්නේ. හරි. ඊට පස්සේ මේ යට සෙට් එකේ මේ row එකේ ඉන්න පුද්ගලයාගේ heart attack එකක් නැහැ 0. කියන්නේ මේ data point එක කිව්වට ඉතින් මෙතන features ගොඩක් තියෙනවානේ. features කිව්වේ මේ columns age sex මේ මේවට මොනවද මේ තේරුම් කියලා හිතන්න එපා වැඩි. නිකන් හිතන්නකො නිකන් blood pressure තියෙනවා, සීනි, sugar levels තියෙනවා. So there are different features like this and based on those features we can give that patient either having a heart attack or not having heart attack. So this is actually our label, and actually what we are trying to predict is also this label. That is why this label is also known as the class variable. හරි අපි එකටම කියන class variable එක කියලත්. හරි right. Class variable එක තමයි predict කරන්න හදන්නේ. We are trying to predict the class variable for unknown data point. So this data point, as you can see, it doesn't have a class variable here. So what we are trying to predict is this data point, which is, again, you can see it is unlabeled because that's what we are trying to predict, right? Okay. Now imagine when you are trying to create a machine learning model using this data set, you have to divide this into testing data and training data. Now, what we are trying to actually do is we are trying to get a value for the accuracy of the model that we are trying to build. In the training data, we are building that model. After building the model, we are using the testing data to test the model. We'll see how that is going to work. Now, so imagine, so we took the testing data out from that whole data set. Right after we so you can see this testing data also has the 1 values and the 0 values as the target variable එකේ එක තියෙන ඒවායි 0 තියෙන ඒවායි ඔක්කොම color මේ තියෙනවා. මේක randomly කියන්නේ ඒක. අපි මේක දෙකට බෙදන්නේ 125ක් හෝ 75ක් වෙන්න කියලා ගන්න පුළුවන්. නැත්නම් ඉතින් තව කෙනෙකුට ගන්න පුළුවන්. ඉතින් 166ක් 133ක් එහෙම කියලාත් ගන්න පුළුවන්. කොහොමත් training data තමයි වැඩිපුරම data set එකකින් ලොකු ප්‍රතිශතයක් training විදිහට ගන්නවා. හරිද? දැන් ට්‍රේන් කරනවා කියන එක අමතක කරලා දාන්න. දැන් අපි මේ ටෙස්ට් කරන්නේ මොකක්ද කියන එක තමයි කරන්න. මේ මොකක්ද කියලා තමයි බලන්න යන්නේ. හරිද? දැන් අපි ට්‍රේන් කරලා හරි මොකක් හරි කරලා නේ මැජික් එකකින් වගේ මොඩල් එක හැදුනා කියන්නකො. දැන් now we are trying to see how to test the built model, right? If we took out the slice of test data, you can see it has both 1 and 0 heart attack possibilities, which means these first 4 people will be having heart attack, and the last 3 people will not be having heart attack. Right now, what we do is remove this target variable, but we save this column in the memory and remove this data. හරිද? අපි data තියාගෙන memory එකේ column එක අපි එක මෙතනින් erase කරනවා. Removing the class variable. Right now, then we have a model that we created earlier, right? We have a machine learning model that we created. Now we can use that machine learning model to predict value for these things නේ. දැන් අපි ගාව machine learning model එකක් හදපු එකක් තියෙන නිසා මේවා අයින් කරලා අපිට පුළුවන් මේවට machine learning model එක පාවිච්චි කරලා එන්නේ මොනවද කියලා බලන්න. Right? Now we are trying to predict value for these things using our machine learning models. So this is the new class variable that we predicted using the model. හරිද? කලින් තිබිච්ච එක නෙමෙයි මේ. දැන් අපි machine learning model එක පාවිච්චි කරලා මේ class variable එක predict කරා. Right. Now we compare this column with that earlier column. ඉස්සෙල්ලා තිබිච්ච එක column එක මතකනේ. මුල එකේ 4 මුල 4 1 තිබුණේ, අග 4 0 තිබුණේ. අග 3 0 තිබුණේ. Now what we do is compare this column with the earlier column, and now you can see this second row doesn't match, and the last row also doesn't match, because in the second row we had 1 but the predicted value is 0. In the last row also we had 0 but now the predicted value is 1. So the machine learning model actually predicted 5 variables correctly out of 7 variables. So the accuracy of the model is 71.43%. This is how you calculate the model accuracy, right? So this is very basic, and so there are many other accuracy matrices, but to calculate accuracy we use this. තේරුණානේ? එතකොට මෙතන මේ අන්තිම එකයි දෙවෙනි එකයි ගැලපෙන්නේ. ඒ නිසා අපි කියනවා 7න් 5ක් හරියට predict කරලා තියෙනවා. ඒ නිසා ඒක මුළු ප්‍රතිශතයක් විදිහට 71.43ක නිරවද්‍යතාවයක් මේ මොඩල් එකට තියෙනවා. Right. I will show you a small demo to demonstrate those things that we learned earlier, and we have some set of other slides as well, but moving forward, without going into those things, I will explain this. Right. Let me exit this. Okay. Okay. Now, what we still see the screen, right? If you don't see it, just let me know. Now, what we're trying to do is use this teachable machine from the Google to explain you how to create different machine learning models. In teachable machine, you can go to get started, and in get started, you have different kind of projects like image, audio, and post projects. But in this session, I will try to go with image project. When you go to image project, you have different uh, you have two kind of projects. To embedded image model is used for the microcontrollers, but for us we will use standard image model. So now you can see you have this class 1, class 2. So now you understand what is class, right? You know what is a class, you know what is training, and then you know where to preview this as well. So in this case we have a separate area to preview it. I will show you. So in this example I will try to differentiate between um, currency notes. So you can, since I choose an image sample, I will have to upload set of image data. So I will upload set of 20 rupees. Now you can either use, as you saw earlier, you can use webcam as well. And if you open webcam, you will get a peek into the your webcam, and then you can show some set of images to that as well. But I will just use upload and upload some images of 20 rupees. Now if when you're uploading it, you can see it uploads into this area. You can actually add several classes. I'm just using 2 classes, but you can add more than that as well. See, so you can see this data set is uploaded. Like so, you can upload to 100 rupees as well. So to save time, I have uploaded both of these. Now you can see 20 rupees and 100 rupees. After you have uploaded those two variable, you can start to train the model. Maybe I'll show that as well. So you might be wondering how to create this set of large data set. So basically what you have to do is get a video, and then you can convert that video into frames. There are ways to convert frames into, the frames into videos like this. You can get a video like this, and then you can convert into frames. Then you can have a large set of images of that set variable, right? Yeah, so I will upload the 100 rupees as well. Then you can see how this happens, but I'm not trying to waste time here, just showing you guys. This is actually very simple to do. In your leisure times, you can do that. Cool. Now, when it's done, you see that this train model button is enabled. When you click the train model, it will start to train it, and then you will get a window like this. After model training, you will get a window like this saying that it is done, and you get a preview. So you can actually, let me switch to webcam and then show it. 100 rupees. Oh, see, so you can see it recognizes between the 20 rupees and the 100 rupees. So this is the basic model that we have built, right, using this teachable machine. Now, this is actually in here, it doesn't actually serve, does not serve the purpose because we can't use it in this website. So now you have to do is convert, or rather export your model. When you go to export it, you have different options. You can use JavaScript, or you can use P5.js, which is what I'm going to do. And also what you can also do is TensorFlow. You can use TensorFlow as well if you are familiar with this. I know that first years and second years doesn't know these things much. So that's why I'm just trying to show you guys this JavaScript version because you are familiar with that. And if you go to TensorFlow Lite, also you can create an Android app as well. You can see it has some examples. They have TF Lite Android example in the GitHub. If you go to that, if you go to there, you get this Android project, and then you can replace your model into this models folder, and you can create an Android app as well. But I'm not going to do that because most of you guys still haven't touched Android, I know. So that's why I'm trying to go with TensorFlow JS, and then into P5.js, you can see this kind of a code is also there. So what you have to do is do these scripts, and then you can preview it on your local environment. Now, to make things easy, I will give you a startup project. So you can go to this repository, Nishan C/P5JS server. I will give these links at the end. What you have to do is you have to download this and then do these things in order. If you don't have Node.js, install Node.js, and then go into that folder. Right afterwards, open up command prompt. And you can say npm install to install all the dependencies. There's not many dependencies. There is only like few dependencies, right? And then you can execute the next command, which is node server.js. Now you can see it is started the server. Now, before moving on, we haven't exported the model, so I will export it. You can click on the download checkbox, and then you can download your model. Now you can see it has been downloaded, and you can move it to your location, and then you can extract that. In this model, you can see there are three files: metadata JSON, model JSON, and weights bin. You don't have to worry about this. That's why I said you don't have to write complex algorithms or rather equations. There are tools that you can use to do these things, but without knowing, you cannot do. Otherwise, you will be lost in the way. So you can copy these three models, these files, and then you can move into the public folder, and then you can paste them here. No, let me open up this code and see. Right. Okay. So this is the boilerplate code. So what you can do is create a model here, model folder. model folder here, and then you can paste those things, and then you can use this code as you can see here to you can see image model URL is in this case not my model. We use this as model, so you have to replace this my model with model, and then carry on with this, and then you can get an machine learning model up and running in your local environment, right? So this is really easy. So I will give you this repository link. So there you can see you have a um, uh, link to a blog post that I have written a while back. There you can follow along, and then you can easily do this classification, and then you can create a web server running in your application, or rather your um, web application running on your local machine to predict some classes as it. So you can see it is quite long. I don't want to go through each and every step of this because we have some more things to talk about, right? So this is not actually very hard. You just follow along. I have written in a very simple manner, so you can go through it, and you can create this local web application. So this is the entire code that we are using to, do that prediction in your local node server. So yes, that is something that you have to try out afterwards. Otherwise, you will not understand, and you will forget these things. මේක පොඩ්ඩක් හරි try කරලා බලන්න. සෙෂන් එකෙන් පස්සේ මේක විතරක්වත් ඊළඟට තව ඩෙමෝස් ටිකක් තියෙනවා. ඒවා නැතත් මේක විතරක් හරි කරලා බලන්න. පුළුවන් වෙයි මොකක් හරි වෙබ් ඇප්ලිකේෂන් එකකට මේ මැෂින් ලර්නින් කොහොමද සම්බන්ධ කරගන්න කියලා ඔයාලට පොඩි අයිඩියා එකක් එයි. හරි. එතකොට මේක එච්චර අමාරු නෑ. JavaScript function තියෙන්නේ. ඔයාලා හැමෝම දන්නා function කියන්නේ මොනවද? හරි. නෝඩ් කියන්නේ මොනවද කියලා දන්නවා ඇති කියලා මං හිතනවා. මේ පහුගිය කාලේ සෙෂන්ස් ටිකක් තිබ්බනේ. ඒ නිසා ඒ නැතත් මේක රන් කරගන්න බැරි වුණොතින් මට කියන්න. මම බලන්න මොකක්ද අවුල කියලා. Okay, so that is demo 1. I hope you can see the slides now. If not, just tell me. So we saw that how to create the accuracy, how to get the accuracy of a model, right? In this example. But in a real world scenario, you have to go beyond accuracy and get some other matrices as well. So one thing is this confusion matrix. Don't be confused. This is actually an n by n matrix. So in simple terms, in the simple case, it is like 2 by 2 matrix. දෙකේ දෙකේ න්‍යාසයක්. හරි. එච්චර අමාරු නෑ. මේකේ තියෙන්නේ ඇත්තටම predict values ටික මේ පැත්තේ තියෙනවා, actual values උඩ තියෙනවා. This is the actual values are on top and the predictors values are on the side. And based on the values, we say we retrieve four numbers. True positive, false positive, false negative, true negative. I will explain this using an example. So imagine, so in our earlier example, we had the cats and dogs, right? So you can see this matrix, this 6 means cats predicted as cats. 3 means dogs predicted as dogs. 1 means dogs predicted as cats. Actual class is dog, no? So you can see in the left side, the actual class is dog, but it is predicted as a cat, right? And the 2 is actual class is cat and predicted as a dog. ඒ කියන්නේ පූසෙක් තමයි ඇත්තටම ඒ උනාට බල්ලෙක් කියලා predict වෙලා තියෙනවා. මෙතන එක කිව්වේ ඇත්තටම බල්ලෙක් ඒ උනාට පූසෙක් කියලා predict වෙලා තියෙනවා. මෙන්න මේ matrix එක තමයි මේ confusion matrix එක කියලා කියන්නේ. So based on where this value is, we give them numbers like true positive, true negative, false negative, false positive. True positive කියන්නේ ඇත්තටම positive. ඒකට true positive කියන්න කලින් අපි ඇත්තටම කියන්න ඕනේ අපේ data set එකේ positive කියන්නේ මොකක්ද කියලා. ඒ කියන්නේ cats තමයි positive, right? ඊට වඩා තව තේරුම් කරොත් එහෙම අපි හිතමු ලෙඩක් කියලා. අපි කියමුකෝ Let's assume we are trying to predict a disease. Let's say we are trying to predict corona or not corona. So intuitively, you know that having corona should be the positive class. කියන්නේ positive කියලා ඉන්න ඕනේ corona තියෙන අයටනේ. නේද? නැති අයට positive කියලා මේ කියන්න බෑ. අපි ඉඳ variable එකට නමක් දෙනවා. corona positive නම් ඒක අපි කියන positive class එක කියලා. corona negative class එකට ගොඩට අපි කියනවා negative class එක කියලා. ඒ වගේ එකක් තමයි මේක කරලා තියෙන්නේ. එහෙම වුණාම අපිට මේ positive negative based on these positive negative variables we can derive this true positive and true negative. ඇත්තටම positive අය ඇත්තටම negative අය. ඇත්තටම catලයි ඇත්තටම dogsලයි. That is true positive and true negative. හරි. වැඩි කන්ෆියුස් කරගන්න එපා. හරි. සරලවම හිතන්න නිකන් true positive කියන්නේ ඇත්තටම positive, true negative කියන්නේ ඇත්තටම negative. I hope you understood. If not, it doesn't matter. You actually don't have to know these things. I'm just, trying to be safe and then, give you guys a basic understanding here. So, um, yeah. So again, then when it comes to these other scenarios where you have a dog, but actually it's a cat, we call them as false negative. Negative වැටලා තියෙනවා. ඒ කියන්නේ ඩෝග් කියලා නේ වැටලා තියෙනවා. අපි කාටද නෙගටිව් කිව්වේ? ඩෝග් කියලාටනේ. ඒකට නෙගටිව් වැටලා තියෙනවා. නෙගටිව් පැත්තට තමයි මේ දෙක වැටලා තියෙන්නේ. ඩෝග්ගේ පැත්තටනේ ප්‍රෙඩික්ටඩ් ක්ලාස් එක ඩෝග්. ඩෝග් කියන්නේ නෙගටිව් ක්ලාස්. ඒ හින්දා මේ දෙකේ ඉලක්කම වැටලා තියෙන්නේ නෙගටිව් පැත්තට. හැබැයි වැරදිලානේ වැටලා තියෙන්නේ. ඇයි වැරදිලා වැටලා කියන්නේ? මෙවුන් ඇත්තටම පූසනේ. ඇක්චුවල් ක්ලාස් එක cats. ඒනොට වැරදිලා ඩෝග්ලා පැත්තට වැටිලා. වැරදිලා නෙගටිව් වෙලා. ඒ නිසා false negative කියලා කියනවා. හරි? තේරුම් නැත්තම් වැඩි හිතන්න එපා. If you didn't understood, just forget about it. But I will just, to be safe, I will just explain it again. So we, at the beginning, we said the dogs are negative class, right? Again, corona nang, not corona කියන එක negative class. හරි. So dogs class is negative class. So these two actually belongs to the dog class because that is the predicted class, right? Dogs, you can see in the top, you have this, I will take this laser point. In the top, you have dogs, which is the negative class. It has value 2, but they are actually not dogs. They are actually cats. That is why under actual class, we have cats. Varadila negative. Unknowingly, this actual class has been predicted as dog. So that is why they are called as false negative, Varadila negative. I'm not going to talk about the false positive because I hope if you understood this false negative, you definitely understand false positive as well. වැරදිලා positive නෑ. ඒ කියන්නේ අපි හිතමු දැන් heart attack ම කියමුකෝ. If you take the heart attack example, if a patient is having predicted as 1 කියලා එනවා නම් heart attack නැති වුණත් heart attack එකක් එන්නේ යාට possibility එකක් නෑ. There is no chance of having a heart attack, but in your model they are predicted as positive people. That is why we call them as false positive. වැරදිලා positive වෙච්ච කට්ටිය. එතකොට මෙහෙම එකක් තියෙනවා. අපි තව පොඩ්ඩක් බලමු example එකක්. So based on these things, you have different kind of matrices like accuracy. Accuracy is actually this. You just have 4 more terms. All the addition of all 4 terms yield in all records. දැන් අර කලින් 7යි කියලා වනේ 7න් 5යි කියලා වනේ ඉරයට. එතකොට 7 හැදෙනවා මේ 4 එකතු වුණාම. හරිද? අර උඩ තිබිච්ච 5 හැදෙනවා මේ දෙකේ එකතු වුණාම. false positive for true true positive true negative. So that is accuracy. It is same as the previous one, and then you have something called a precision, and you have recall, F1 score, specificity, sensitivity. Like so, if there are different matrices, you don't have to know all those things. We just want to know the first 3. Even that is also not really important. You can have like you can have only the one first first 3, right? But you just have to know the first one, the accuracy. That is also fine if you are first year, batch 19. batch 19 කට්ටිය මේ පළවෙනි එක වගේ දැනගත්තා නම් ඇති. But just understand and uh, just know that there are some other matrices as well, because these matrices are not there for like as joke. They are actually represent some useful value, useful meanings, right? So let's say take this example again. Now we said that it is model accuracy is having 71%, and it has predicted the last row as differently and the second row differently. Now what we are trying to do is, to get those four values: true, positive, true, negative, false, positive, false, negative values out of these 7 records. Let's try to divide this. So as I said earlier, first of all, what we have to do is define what is the positive class. So having an heart attack is the positive class in this case. කියන්නේ heart attack එකක් තියෙනවා කියන එක තමයි positive class එක කියලා අපි හඳුනගන්නේ. heart attack එකක් නැති එක positive කියලා ගන්නත් පුළුවන්. ඉතින් ඕන කෙනෙකුට ඒක ඕගොල්ලන්ගේ කැමැත්ත හරි. අපිට ඉතින් අර කතාව කියන්න පහසුයිනේ positive කියන්නේ තියෙනවා කියන එකනේ. ඉතින් ඒ අදහසින් තමයි මෙහෙම එක කියන එක output එක positive එකට අපි ආදේශ කරගත්තේ. Right. So first one is a true positive, second one is a false negative, true positive, true positive, true negative, false positive. So you can see, so only issue we have is this with true, false negative and false positive, right? So, uh, so you can see false negative means that the zero has been predicted. Zero zero has been predicted, but the actual value is 1. එක තියද්දි 0 වෙනවා නම් false වැරදිලා negative වෙලා තියෙනවා. False negative. Right? Mistakenly, it has been predicted as a 0. That is why they are called false negative. Next one is true positive, because those both are true. Both are true. Again, true positive. Both are negative. So that is true negative. Both are negative. That is true negative. And then we have actual value is 0, but predicted as 1. Verdila positive, mistakenly predicted as a 1. So that is why we call them as false positive. Now what we have to understand is this false positive. Positives are not actually really very dangerous. False positive were dangerous නෑනේ. ඒ කියන්නේ මෙහෙම කිව්වොත් එහෙම දැන් heart attack එකක් තියෙනවා කියලා sorry නැති කෙනෙකුට තියෙනවා කියලා predict. Imagine you don't have a heart attack, but your models tell you that you have a heart attack. That is not very dangerous, because after doing some more tests like blood tests or pressure tests, the doctor will tell you, okay, that is wrong. You actually don't have a heart attack. So that is why that is not very dangerous. But this case, false negatives are dangerous, because you are having a possibility to get a heart attack, but your model says 0. කියන්නේ heart attack එකක් තියෙන්න පුළුවන්. ඒ වුණාට ඇත්තටම වගේ මොඩල් එකකින් කියනවා නැහැ කියලා. අන්න ඒක තමයි dangerous case. ඒ නිසා sorry. ඒ නිසා අපි කියනවා. So because since you uh, in the actual values they say that you are going to have a heart attack, but in the predicted case you don't your model says that you will not get a heart attack. So that case is more dangerous rather than saying that actually you will have a heart attack while you don't have a heart attack. So that is why we call that is as dangerous. And because that is dangerous, if you go into that matrices like precision and recall, as I showed you earlier, you can see this way the equation to calculate recall, you have a term for false negative. මේ recall කියන එක calculate කරන equation එකේ false negative කියන term එක තියෙනවා. එතකොට ඔයාගේ so since you have that false negative term in the recall equation, you have to understand that if your false negative rate is high, your recall is going to drop. When you increase the false negative rate, your recall value gets decreased, right? Again, false negative value එක වැඩි වෙද්දී recall එක අඩු වෙනවානේ. එතකොට ඔයගලන්ට තේරෙනවනේ මේ වගේ ප්‍රොබ්ලම් එකක් මැෂින් ලර්නින් වලින් මොඩල් කරද්දි මේ වගේ දැන් ෆෝල්ස් නෙගටිව් ඩේන්ජරස් වෙන කේස් එකක්. හරිද? ෆෝල්ස් නෙගටිව් ඩේන්ජරස් වෙන්න හේතුව තේරෙන්නේ නැති කියලාත් මම හිතනවා. ඒක තේරුම් නැත්තම් අහන්න. මේ ෆෝල්ස් නෙගටිව් ඩේන්ජරස් උනේ තියෙන කෙනෙකුට නෑ කියලා ප්‍රෙඩික්ට් වෙච්ච නිසා. එතකොට මෙයා හැරිලා ගෙදර ආයිනේ ඉතින්. මට හැදෙන්නේ නෑ කියලා. හැබැයි මෙයා මොකද කරන්නේ? තියෙනවා කියලා ප්‍රෙඩික්ට් වෙච්ච ගමන් මේ තව ටිකක් ඩොක්ටර්ලා හම්බෙලා චෙකප් කරලා ඒක එයා විසඳ ගන්නවා. හැබැයි මෙයාගේ හිතේ තියෙන බය අඩු වෙනවනේ. ඒක භයානකයිනේ. ඒ නිසා තමයි ඒක dangerous. So this case is dangerous, and because that is dangerous, if your model's recall value is low, you have to change your model. ඒ කියන්නේ ඔයාගේ model එකේ recall එක අඩු වෙනවා. recall එක අඩු වෙන්න හේතුව මොකද්ද? false negative rate එක වැඩි වීම. මොකද අනිත් terms දෙක වෙනස් වෙන්නේ නැහැ නේ. දෙකේ උඩත් තියෙන්නේ true positive, under the line is also true positive. Only this term is affecting to the recall. So that's why if your false negative rate is high, your recall drops. And if your recall drops in this kind of a machine learning problems, your machine learning model is not very good. හරිද? තේරුම් නැතුණාට කමන්නේ. ඒ උනාට පොඩි අයිඩියා එකක් තියාගන්න මේ කියන්නේ. දැන් recall එක අඩු වෙනවා කියන්නේ false negative rate එක වැඩි වෙනවා කියන එක. ඒතකොට recall එක අඩු මොඩල් එකකින් මේ වගේ ප්‍රශ්නයක් විසඳන්න බෑ. ඒක වැරදිනේ ඇත්තට. මොකද ඔයාගේ machine learning model එකේ recall එක අඩුයි කියන්නේ ඔයාගේ false negative rate එක වැඩි. ඒක භයානකයි. ඔයාගේ මේවා වැඩි වුණත් කමන්නේ. ඒක accuracy එකට බලපානවා තමයි. දැන් false positive වැඩි වුණොත් accuracy අඩු වෙනවනේ. ඒකත් වැරදිනේ. 0.1 කියලා predict වෙන එකත් වැරදිනේ ඇත්තට. ඒ වුණාට ඒක ප්‍රශ්නයක් නෑ. ඔයාගේ මේක ඕකේ නම් false negative rate එක ඕකේ නම් ඒක අඩු වගේ එක තියෙනවා නම් accuracy එක අවුලක් නෑ recall එක. ඒ කියන්නේ recall එක ගොඩක් වැඩි නම් හොඳයි. හරි. හරි. ඒක තේරුම් නැති වුණාට කමක් නෑ. තේරුණා නම් හොඳයි. තේරුම් නැත්නම් ඔයගලන්ට ඒක ඉස්සරහට ඉගෙන ගන්න ලැබෙයි. When it comes to a level 4 projects, also you will, you have to use these things with proper understanding. That is why I'm trying to say, okay. Otherwise, you will get various questions from your evaluators. Why did you use accuracy? Why haven't you used recall? Why haven't you used precision? Right? So you have to understand why these matrices are there. So I'm not going to explain F1 score and everything else. Just accuracy, precision, and recall. You have to have a basic understanding why those are there and in what cases we are going to need them. Okay, moving on. So another term you will come across is this KDD, knowledge discovery in databases. So you can see this is actually very similar to the very first diagram that I show that converts data into actions. So here also you can see we have the data and then we go to target data, then we go to pre-processed data, then you go to transform data, patterns and information. Right? You can see this machine learning actually comes under the data mining process. And you have to know that before data mining, you have to do these two things, pre-processing, transformation and selection as well if you have some garbage data. So we have to do that as well. I will try to explain that as well, and then we will try to go to the next demonstration, right? So data transformation and pre-processing is most important work. That is actually sometimes 99% of the work. ඔය machine learning data scientist ලා කියලා තියෙනවනේ. ඒගොල්ලෝ ගොඩක්ම කරන්නේ මේ වැඩේ තමයි. machine learning කියන එක දැන් එච්චරම අමාරු වැඩක් නෙවෙයි. දැන් දැක්කනේ ඔයගොල්ලෝ අර image classification එක කොච්චර ලේසියෙන් කරාද කියලා. එතකොට ඒ වැඩේ නෙමෙයි. ඇත්තටම මේ transformation, pre-processing කියන එක තමයි data scientist කෙනෙක් දැනගන්න ඕනේ ප්‍රධානම දේ. machine learning කරනවා නම් දැනගන්න ඕනේ ප්‍රධානම දේ. So that is why I am saying that it is sometimes 99% of the work. So, okay. So I will tell you few things that we are trying to do when it comes to transformation and pre-processing. There are many other ways, but I'm trying to just give you some examples. Okay. මේ example ටිකක් දෙන්න තමයි හදන්නේ. මිසක් මේක කියලා දෙන්න නෙමෙයි. ඔයගොල්ලන්ට demo එකේදී පොඩ්ඩක් පෙන්වන්න පුළුවන් මේක. First thing you have to understand is you have to handle the missing values. Then ඔය ලොකු data set එක missing values තියෙන්න පුළුවන්. There could be like if the data set is like 10,000 rows, you will have some missing values. Then you have to replace those missing values. So first thing you have to understand, if you have missing values in the target variable, if you have missing values in the class variable, you have to drop those things. ඒ කියන්නේ අපි predict කරන්න හදන variable එක තියෙනවනේ. දැන් අරක ඉඳන් 0ද 1ද කියන එක. අන්න ඒ column එකේ missing values තිබ්බොත්. If you have missing values in that class variable, you cannot use that data point now. So you have to drop that. That is what this code segment does. But you can do like with other than deleting rows, you can if you have missing values in other columns, අනිත් features වල missing values තිබුණොත් අපිට ඒවා replace කරන්න පුළුවන් mean එකෙන්, median එකෙන්, mode එකෙන්. ඒ කියන්නේ average එකෙන් හරි මොකකින් හරි replace කරන්න පුළුවන්. Otherwise we can assign a unique value, or actually we can use another machine learning model to predict the missing values itself. Missing values ටික fill කර sorry missing values ටික fill කරන්න විතරක් වෙනම machine learning models හදන්නත් පුළුවන්. ඉතින් ඒක ඉතින් ඔයාට ඔයාගේ ප්‍රශ්නේ හැටියට තමයි. ඔයාට හොඳම accuracy ඕනේ නම් ඔයා ඒක කරන්න. Yeah, and another thing is you can switch to machine learning models which support missing values. Missing values තියෙන machine learning models, missing values support කරන machine learning models වලට switch වෙන්න පුළුවන් තියෙන machine learning model එක අයින් කරලා. Okay, another pre-processing step that you have to do is handling the class variable, class imbalance variable. This is actually I can show you in the demo. So in your data set, if I take the cat and dog example, you might have a higher number of cats than dogs, or the other way, you can have higher number of dogs than the cats. ඒ කියන්නේ බල්ලොයි පූසොයි බල්ලෙක්ද පූසෙක්ද කියලා ප්‍රෙඩික්ෂන් එකක් කරොත් ඔයගලන්ගේ data set එකේ ඉන්න පුළුවන් බල්ලන්ට වඩා පූසු. ඒ කියන්නේ පූසෝ ඉන්න data point ප්‍රමාණය වැඩි නේ. එහෙම වෙන්න පුළුවන්. එතකොට ඒ වගේ වෙලාවකට අලුතෙන් පූසෝ මොකද හදන්නේ? එතකොට කරන්න තියෙන්නේ පූසෝ ඉන්න data set එක. When you have that kind of issue, when your target variable having one class is having less than the other class, what you can have is you can create multiple variations of the less value class. I will explain that, then you will understand. We use that smart synthetic minority over sampling technique. There is a technique like this to do that. Then again, it is also very easy. You just have with 3 lines you can do that, right? It is very easy. I will explain that. Otherwise, other than smart, so smart comes under this resampling, oversampling, and not undersampling. Smart comes under that. There are other things called k-fold cross-validation, resample with different ratios. There are many ways, as you can see. So since this is a basic basic guidance to the things that you will come across, you just have to know that there is a pre-processing step called handling class imbalance, and there are ways to do that. Class imbalance කියලා එකක් තියෙනවා මෙහෙම. ඒ කියන්නේ classes දෙක සමාන නැති වෙන එක. බලන්ට වඩා පුසු වෙන එක. නැත්නම් heart attack එක ගත්තොත් heart attack තියෙන කට්ටියගේ ප්‍රතිශතය වැඩි, heart attack අඩු අයට වැඩිය. එහෙමනේ සාමාන්‍යයෙන් ඕනෑම ප්‍රශ්නකදී අපි දැන් ඇත්තටම නම් heart attack හැදෙන ප්‍රමාණය අඩුයි කියලා හිතුවොත් එහෙම ඇත්තටම ඉතින් heart attack හැදෙන්නේ සාමාන්‍යයෙන් 5 දිනකකින් එක්කෙනෙකුට වගේ කියලා කිව්වොත් එහෙම දැන් ඒගොල්ලෝ එහෙම කියන අහලා ඇති නේ. ලෝකෙ මෙච්චර ප්‍රමාණයකින් මේකට තමයි මෙහෙම හැදෙන්නේ කිව්වහම ඉතින් අනිවාර්යෙන් ඒ class imbalance issue එක තමයි කියන්නේ. එතකොට ඒක විසඳන්න පුළුවන් වෙන්න ඕනේ අඩුවෙන් තියෙන එක වැඩි කරන්න ඕනේ. කියන්නේ heart attack හැදෙන කට්ටිය වැඩි කරන්න. එතකොට ඒක කරන්න ඇත්තටම මේක ප්‍රායෝගික නැති නිසා අපි කරන්නේ data set එකෙන්ම කෑලි අරගෙන data set එකේම තියෙන heart attack හැදෙන කට්ටියගේ data points අරගෙන ඒව replicate කරනවා. ඒවා දෙක හදනවා කියන්නේ එකම value එක නැතුව චුට්ටක් වෙනස් කරලා අපි ඒක බලමු, right? Scaling is actually very simple. Some values have large numbers, some values have small numbers. You have to decrease those limits into the same range. ලොකු numbers තියෙනවා නම් පොඩි කරන්න ඕනේ මේ එකම range එකට ගේන්න ඕනේ ඔක්කොම. හරිද? එතකොට ඒකටත් එක විදි තියෙනවා ඉතින්. There are different ways to scale these things like min max scaler, standard scaler, max ABS scaler. Likewise, there are different scalers. No, don't worry, you don't have to understand this equation. You just have to import the relevant scalar that you want to use and then you have to apply it. That is all you have to do. But you have to understand why we are doing this, because in some machine learning models, mostly all of the machine learning models actually rely on the numbers, as I said earlier. So actually the output or the result of your machine learning models strongly depends on how your numbers are. Missing values නැති ලස්සනට pre-process කරපු scale කරපු ඊට පස්සේ තව මොනවද අපි කරේ class imbalance නැති කරපු හොඳ data set එකක් තියෙන්න ඕනේ හොඳ accuracy එකක් ගන්න. හරි. Okay, different libraries is actually for scientific computation. NumPy is for like handling arrays, high-level mathematical functions. And Keras, we are not going to talk about Keras today. They are used for like deep neural networks. If you are working with neural networks, you have to use Keras. Okay, so yeah. Okay, another thing, TensorFlow again for neural networks. Pandas is for manipulating your data and data structures and tables. And the platform that we are using today is called the Google Colab, which you can use to do different machine learning experiments in the cloud without installing Python onto your local machine. Again, local වැඩ කරන්න සහ data machine learning experiments කරන්න platform එකක් තියෙනවා Google Colab. අපි ඒක තමයි use කරන්නේ. හරි. Okay. Final demo 2. After this, I promise you that I will let you go. Okay, let me go to that repository again, and then you can go to this second link, heart attack prediction code. Let's give it a second. Okay, Google Colab is like this. It is like, very simple. It is kind of a document that you know in Google Docs, right? You have like a different set of cells here. Cells කියලා જાතියක් තියෙනවා. Code cells වෙන්න පුළුවන්, text cells වෙන්න පුළුවන්. Text cells වල තමයි මේ text දාලා තියෙන්නේ. Code cells වල තමයි මේ code දාලා තියෙන්නේ. හරි. First of all, what you have to do is if you come across to this link, you have to file and go to save a copy into your drive, and then afterwards you have to connect. So what it does is allocate some space in Google Cloud for you to continue with this experiment actually. And you can actually load data from your Google Drive as well if you go to here. Okay. Enable. Okay, it's connected down. After it's connected, you can see the RAM and the disk space. And like when you go to this place, you can see that you can upload files to here, or you can connect Google Drive as well. Then you can load some data, and you will get some sample data as well. But for this case, I'm not using that. I'm using that earlier example that I showed you that that heart attack possibility data set. Now you can see this data set have sex as male, female. So you have to understand these are text, and you have to convert this text into numbers, right? I said that earlier. Again, me text නේ තියෙන්නේ මේ machine learning models වලට දාන්න බෑනේ. ඒ නිසා මේව numbers කරගන්න ඕනේ. එතකොට අපි use කරන එක මේ අර කලින් කියපු pandas use කරනවා, data set එකට numpy use කරනවා. ටිකල් අපි හදපු model එක save කරන්න load කරන්න වෙන තැනකට ගෙනියන්න වගේ තමයි ඒක යූස් කරන්නේ. ඊට පස්සේ plot හදන්න plot libraries තියෙනවා. ඊට පස්සේ scale එකක් අපි යූස් කරනවා. standard scale එක. ඊට පස්සේ මේ ටික අපි කරගෙන යද්දි බලමු. ඒ වගේම මේ තියෙන models, data models තියෙනවා අපි ගාව XGB classifier කියන machine learning model එක, random forest, decision tree, SVC එහෙම නැත්නම් support vector classifier කියන එක ඔයාලට ගොඩක් ඒවා යූස් කරලා බලන්න පුළුවන්. ඉතින් මේ හතර විතරක් නෙමෙයි. හරි. Okay. I will try to run this code, and then this actually I'm not going to talk about this data visualization cells because it is really easy. I'm just using this AutoVis library to get some visualizations like this. You can see we have scatter plots and this kind of different statistical plots that you can create using this data set, because as I said, preprocessing is the most important part. So to preprocess, you have to understand how these variables and how these variables behave, right? Otherwise, you cannot do that. So if you are trying to go to a PhD level or MSc level in machine learning, you have to choose your machine learning model based on these different visualizations. ඒ කියන්නේ සමහර machine learning models තියෙනවා features මෙන්න මේ වගේ bell curve තියෙන්න ඕනේ. bell curve එකක් වගේ feature එක තියෙන්න ඕනේ, නැත්තම් දාන්න බෑ. දැන් regression වගේ machine learning models තියෙනවා. feature set එක features තියෙනවනේ මෙහෙම. එතකොට ඔක්කොම features මෙහෙම bell curve එකක් විදිහට හදා ගන්නවා. එක එක transformation pre-processing කරලා. ඉතින් ඒ වැඩේ අමාරු වැඩක් කියලා වලට තේරෙනවනේ. සමහර විට දැන් ඒ සමහර features වල ලඝු ගන්න වෙනවා අපිට. ලඝු අරගෙන ලඝු වලට convert කරලා ලඝු වලින් දෙන්න වෙනවා. එතකොට සමහර විට මෙහෙම වෙන්න පුළුවන්. ඉතින් ඒකේ ට්‍රාන්ස්ෆෝමේෂන් කරලා බලලා එහෙම හදන්න වෙනවා ඒ මැෂින් ලර්නින් මොඩල් එක දානවා නම්. ඉතින් ඒ වගේ ඕගලන්ට තේරෙන්නේ නැති එක දේවල් කරන්න ඕනේ මේ විසුවලයිස් කරගන්නේ ඒ නිසා. හරිද? එතකොට ඒක තමයි කරලා තියෙනවා. මම ඒක ගැන වැඩි කතා කරන්නේ නැහැ. අපි මොඩලින් පාර්ට් එකයි රිප්‍රෙඩික්ෂන් පාර්ට් එකයි බලමු මේක රන් කරන්න. run time and go to run all. This is actually like running your code in the command line. So you have typed your code, and each cell can be run individually as well. But I'm running all cells. So you can see if you go to this one, it is running this visualization at the moment. Yeah. Visualization is done, and then we have done all the cells. You can see run කරපු පිළිවෙලට 4 5 6 7 මෙහෙම ඇట్లా තියෙනවා. Okay, so we have took our data set from the GitHub, same repository as I showed earlier. We have how long? Like 10 minutes, right? Okay, that is fine. Now you can see we are using the df.info. These actually that methods coming under these libraries. දැන් pandas කියන library එකෙන් තමයි මේ info method එක එන්නේ. ඉතින් ඒක එන්නේ කොහෙන්ද කියලා දැනගන්න අවශ්‍ය නැහැ ගොඩක්. ඔයාලා දැනගන්න මේකෙන් කරන්නේ මේකයි. අපි බැලුවොත් මේකේ ඔයාලට පේන ඇති ඒ data type එක පෙන්නනවා. integer float ඔක්කොම උනට මෙන්න මේ sex කියන එක object තියෙන්නේ. So you can see the sex variable is object because it is actually a string variable, right? So you cannot use object variables to machine learning. So you have to convert that. And before that, we are trying to see what kind of features having null values. So you can see the test trest bps having 4 null values, chol variable having 8 null values. So this you have to have an understanding about these variables as well. You can go to this link to check the data set, and you can see there are different these are the features. So if you go to like let's say what is test trest bps, the explanation for trest bps is in the 10th line. So if you go to 10th line, you can see trest bps is resting blood pressure in 1 millimeter for in 1 millimeter. This is actually the pressure on admission to the hospital එකට ඇතුළත් කරපු වෙලාවේ resting blood pressure එක. හරිද? රසදිය මිලිමීටර වලින් දීලා තියෙනවා. රයිට්. එතකොට ඒ විදිහට ඒ ෆීචර්ස් මොනවද කියලා ඔයගොල්ලන් මේ ලින්ක් එකෙන් බලන්න පුළුවන් එක එක ෆීචර්ස්. හරි. Right. So you can see there are different some having null values. We have to remove that as well, and also you can see target variable is also having a null value. So first of all, we are trying to do is we remove that row from that data set because without having a value for target, we cannot use that data point to anything, right? And then and then what we are trying to do is remove the null values with mode. I said earlier we can remove null values with mode. So you can see a slope variable, FBS, EXANG, CA, and THAL. There are 5 variables here, which are taken from here. And then we fill the NA. NA means null values using the mode of that particular variable. And we take another 4 variables, test trest, bps, chol, like so, and then we fill the null values of that variable using the mean. Yeah, it actually depends on your opinion, right? You have to do some you can change these things, you can select some other way to remove null. That really doesn't matter. You just have to select a way to, I mean, you can change these things and see how the accuracy behaves. මේවා වෙනස් කරලා බලන්න පුළුවන්. දැන් මේක mode එකකින් නැතුව මේක mean එකකින් replace කරලා කොහොමද accuracy එක වෙන්නේ. ඉතින් ඒ වගේ තමයි. ඉතින් ඒක තමයි මම කිව්වේ මේ 99ම තියෙන්නේ මේ pre processing. Okay, after we remove these nulls, we can check again who are having null values, and you can see all are 0. And then, so I said this x variable, we have to change it to number. What I have done is I have replaced the value male with the probability of male and value female with the probability of female. ඒ කියන්නේ මේ data set එකේ ඉන්න data point එකක් ගත්තොත් ඒක ඒ point එක male වීමේ සම්භාවිතාවය තමයි අපි replace කරලා තියෙන්නේ male කියන අකුරු 4. හරිද? දැන් කවුරු ඒක මම කිව්වනේ දැන් මේකට 1 2 කියලා දෙන්න පුළුවන්. male කියන්නේ 1, female කියන්නේ 2 කියලා දෙන්න පුළුවන්. එතකොට male කට්ටියට මේල් ඩේටා පොයින්ට්ස් වලට ටිකක් හොඳට සලකන්න ගන්නවා ඩේටා මේ මැෂින් ලර්නින් මොඩල් එක. ඊට පස්සේ පුරුෂාධිපත්‍ය ප්‍රශ්නයක් යනවා. ඒ නිසා අපි කරන්නේ සමාන විදිහට දෙකටම සලකන්න පුළුවන් වැලියු එකකින් රීප්ලේස් කරපු එක. එතකොට ඔයගොල්ලන්ට පේන ඇති මේල් ඩේටා පොයින්ට් ඔක්කොම මේ 0.868, female, all the female points are 0.31. This is actually the probability of getting a female data point in your data set. This is actually the probability of getting a male data point in your data set. This is the equation to convert that. So yeah, that is really easy. And then we save this data using the pickle library. We have to use it later. I will tell you why we need to use that later, because if you come across a new data point, then my data set එකේ නැති data point එකක් ආවොත්, you have to transform that data point as well, no? So you don't get this kind of transformed data. You always get this data set. අලුත් data point එකක් එන්නේ මේ විදිහට 63යි මේල් ඔහොමනේ එන්නේ. එතකොට මේ මේල් කියන එක හරි නැත්තම් දැන් මේ වගේ null value එකක් ආවොත් ඒ null value එක අපි replace කරේ මොකෙන්ද මේකේ mode එකකින්. එතකොට ඒකේ mode එක අපි save කරන් තියන් ඉන්න එපා ඊළඟ data point එකට apply කරලා. You have to save those modes, means, and probabilities. So you can use it in a new data point, right? අලුතෙන් predict කරන්න එන data point එක දැන් target variable එක නැති එකක් අපිට හම්බ වෙනවනේ අලුත් patient කෙනෙක්. So we have to predict that. To predict that, we have to do all this transformation again to that data point. So to do that, we have to save these values. So that is why I am actually saving this data frame here. Okay, now let's see that class imbalance issue. We said earlier, you can see we have less number of zeros and higher number of ones. So what we do is we use SMOT, synthetic minority oversampling technique, you can see using 3 lines, you can do that. And afterwards, after applying that, you can see we have removed the class imbalance of that data set. ඒ කියන්නේ මේකේ වෙන්නේ මේ බිඳුවේ sample එක වැඩි කරන එක. එතකොට බිඳුවේ sample එක වැඩි කරන්නේ ඒකේ බිඳුව තියෙන ඒවාට සමාන ඒවා ටිකක් auto generate කරලා replicate කරලා ඒ වගේ values චුට්ටක් එහා මෙහා වෙනස් කරලා දැන් උදාහරණයක් විදිහට මේ වෙන icon එකේ තියෙන අපි ගමුකෝ උදාහරණයක් විදිහට දැන් මේ එකේ variable එකක් තව එකක් හදන්න ඕන නම් මේ data point එක වගේ අපිට පුළුවන් මේක 355 වගේ කරන්න මෙන්න මේක 54 නැතුව. ඒත් අපිට කියන්න පුළුවන් 355 වුණත් මෙයා heart attack එකක් හැදෙන්න පුළුවන් කියලා. එතකොට ඒක 5 කියලා වෙනස් කරලා ඒ තව එකක් හදනවා. Right? That is what we do in the class imbalance, removing class imbalance. And then then we are coming under the to remove the to split the data set into train and testing set. Remember I told you that this is like an x and y kind of a problem. අර y value එක ගන්න එක y සමානයි mx වගේ. So you remember I told you in the beginning that this is kind of a equation that we need to predict y using m and x. So you have to understand we have to have set of y variables and set of x variables. And also we need to have training set and testing set. So that is what we are doing here. We are getting x train, x test, y train, and y test using this method, train, test, split method, right? After doing that, if you look at a data point, you will get kind of an array like this. මේක කරාට පස්සේ data point එකක් දිහා බැලුවොත් ඔයගලන්ට පේන්නේ මෙන්න මේ වගේ array එකක් කියන්නේ. ඒත් ඔයගලන්ට පේන්නේ නැති මේ සමහර ඉලක්කම් 200 ගණන්, ඒ වුණාට සමහර ඉලක්කම් 0 point ගණන්. නැත්තම් 2යි. නේ? නැත්තම් එහෙම. එහෙම නෙමෙයි නැත්තම් 0.31. So some data points are much higher than some data points. So that is why we need to use a scaler. Scaling මතකනේ අර ලොකු Apple ගෙඩිය පොඩි කරේ. So we are using standard scaler to do this. After doing the standard scaler, this will come to like um, small values. I will show you how to. Maybe we can add another um standard scaler. Yeah, after the standard scaler, I will visualize another data point to show you guys that how we have done it. See, now you can see the 41 has become minus 1.6 something. So similarly, we have transformed all these features into this set of scaled values. That is what standard scaler has been doing, right? Okay, now we are ready to apply our machine learning models. So we applied the decision tree classifier first. So you can see there are different in the decision tree method. You can see different parameters: criterion, random state, max depth. You can change these parameters as well. Like if you, so we are taking this decision tree classifier from the library called. Let me go up and see. Decision tree comes under sklearn library. So if you search sklearn decision tree classifier, and if you go to the documentation of that, you can see there are different parameters. So criterion can have either Gini or entropy. So you can try, what you can do is you can try to change. Where did we have? No, this one, right? So you can change entropy into Gini criterion. මේ ගිනි එන්ට්‍රොපි කියන්නේ මොනවද කියලාත් ඔයගොල්ලන් ඉගෙන ගන්න අර මොඩියුල්ස් වල ඒකට ගොඩක්ම ඇටෙන්ෂන් එක දෙන්න අවශ්‍ය නැහැ මේ මම කියන්න හදන්නේ මෙතන පැරාමීටර්ස් වෙනස් කරලා ඔයගොල්ලන්ට පුළුවන් මේ accuracy එක behave වෙන්නේ කොහොමද බලන්න. Right, you can do that as well. So we call that process as hyperparameter tuning. You can change the parameter set and then you can try to come up with different accuracies. So after you do that, you see that there are different methods that we use to train and then predict, right? And then we calculate the confusion matrix, and then we can create the accuracy score. You can see accuracy of this model is 80% 3, and you can see we get that the confusion matrix as well. Confusion matrix එකත් ඇවිල්ලා තියෙනවා. එතකොට බලන්න පේන ඇති අර true negative, true positive, true negative, false negative, false positive. We have like different values for those four values. Without resting on decision tree, we will apply the random forest as well. Random forest is another classifier. Decision tree කියන්නේ අර ඔයගොල්ලන් දැක්කන ඉස්සෙල්ලා අර if else statement තියෙන එකනේ. එතකොට random forest කියන්නේ ඒ වගේ trees. දැන් ඒක tree එකක් වගේනේ, ගහක් වගේනේ. ඒ වගේ trees ගොඩක් හදලා හොඳම එක තෝරනවා වගේ වැඩක් තමයි random forest එකෙන් කරන්නේ. ඒ කියන්නේ forest කියන්නේ, right? So so we apply random forest as well. Again we get like we have a better accuracy in random forest, 87.87, but we and earlier we had like 80. Okay, so we are running out of time. I hope I can continue like for another 15 minutes. If you have any if you want to leave, it's okay, you can leave. But if you can stay, I will explain the rest of the code. Okay, so yeah, machine learning random forest classifier. So we get like you can see we have reduced the number of um, what did we call that? True, sorry, false positives, right? False positives. So in the earlier we had like false positive 8. Now in the random forest we have 3. But false negatives are same as earlier, right? We have like 5 false negatives, and here also we had 5. So we saw that we have to reduce the number of false negatives, right? Remember, false negative dangerous නිසා ඒක අඩු කරන්න මහන්සි වුණා නම් හරි කිව්වනේ. එතකොට ඔයගොල්ලෝ මේවා ට්‍රේන් කරනකොට ඒවත් බලන්න ඕන කියලා තමයි මම කියන්න උත්සාහ කරන්නේ. Now we'll try to apply support vector machine as well. So here you can see we have like 87, same accuracy as the random forest. Same accuracy, but you can see we have reduced the number of false negative by 1. We have 4 false negatives. Here we have 5 false negatives. We have basically reduced that, right? So I think in this scenario, random forest, I mean the support vector machine classifier is much more accurate than the random forest classifier. Even though the accuracies are same, accuracies දෙක සමාන වුණත් support vector machine is having a good performance in this context. මේ වෙලාවේදී අපිට තේරෙනවා මේක ටිකක් හොඳයි කියලා නේ. ඒක තමයි ඒ ගොඩක් use කරලා බලන්න ඕනේ thing. And another machine learning model, we use X gradient boost classifier, XG boost. Here we get like reduced to 86, and this is the confusion matrix. Now we can plot the confusion matrix as well. So we selected SVC, or the support vector classifier, as the best classifier, and then we create the plot for the confusion matrix using that machine learning model. And you can see it is hard to see, but you can see there is 4 here, and there's okay. And yeah, so also another thing that you can do is to check what are the best what are the features that contributed more. Like you can see CA, CP, THAL, 6, like so are the most contributing factors for a heart failure. කියන heart failure එකක් වගේ එකක් වෙන්න ගොඩක්ම බලපාලා තියෙන සාධක බලන්න පුළුවන්. මේ machine learning model එකක් ඉවරුනහම අපි ඒකට කියනවා මේ feature importance කියලා. හරිද? feature importance එක බලන්න පුළුවන්. එතකොට CA කියන එක තමයි ගොඩක්ම බලපාලා තියෙන. බලමු CA කියන්නේ මොකක්ද කියලා. කො අපේ data set එක CA කියන්නේ 44 number of major vessels colored by fluoroscopy. ඒ කියන්නේ කොච්චර vessels ගාන fluoroscopy කියන scan එකේදී තිබිච්ච vessels ගාන වගේ value එකක් තමයි. හරි. ඒක ඉතින් medical term එකක් නේ. Otherwise that other than that we have CP, THL. Let's see what are those. CP is 9. Chest pain type. So different chest pain type is also contributing very much contributing factor for heart disease. And then again, the other thing was THAL. THAL was 51. 51 is, let me check. Okay, it is kind of a defect in the heart, like normal defect, fixed defect, reversible defect kind of a thing. And you can see sex is also an important factor. Slope is also. Likewise, you can see different features how they contribute to this problem. Again, heart attack එකක් බලපාන ඒත් වෙන සාධකත් ඔය බලන්න පුළුවන්. දැන් after you create this graph, you can remove these features as well. Then කලින් train කරද්දී, before you train the model, you can remove this REST, ECG, CHOL, LBS, FBS. You can remove these three features because they don't actually contribute to the final result, right? They are like having a small percentage of contribution. So you can try to remove these three variables and then again try to predict using another model and see how the accuracy increases. So likewise, you can do different things and try to come up with a good prediction like this. Machine learning data point like this. After you get a machine learning model, I mean a data point like this, what you can do is first of all load the data that we saved earlier, and then load the model and load the scalar that we created earlier, and then apply those transformations onto this new data point. අලුතෙන් හම්බෙච්ච data point එක. අලුත් patient කෙනෙක් ආව කියන්නේ හෙට. එතකොට එයාගේ මේ ටික මැනගෙන ඒ ටික අපි machine learning model එකට දාන්න කලින් අපි අර කරපු transformation ටික කරන්න ඕනේ. ඉතින් null අයින් කරා, sex මාරු කරා, sex මාරු කරා කිව්වේ මේ වචනේ මාරු කරා. හරි ඉලක්කම් වලට. and ඊට පස්සේ මේ data point එක scale එක පාවිච්චි කරලා scale කරා. ඊට පස්සේ අපිට පුළුවන් model saved dot predict කියලා දාලා අපේ data point එක ඒකට මේ apply කරා. එතකොට අපිට print කරලා බලන්න පුළුවන් මොකද්ද prediction එක 1 කියලා එනවා. කියන්නේ එයාටත් heart disease එකක් එන්න පුළුවන් කියන එක. heart attack එකක්. right? Right, that is the code actually. That is what I wanted to show you guys. But another thing to notice, you have to understand this running on what are the different versions of these libraries. Otherwise, you cannot. Sometimes, if you save now, imagine your sklan is in 0.22, but in your local machine, your sklan is 0.24, and then so your model has been saved using this version, but you may not be able to load that model using a newer version. Again, අලුත් පරණ version එකකින් save කරොත් දැන් මේ version එක 22 නේ. ඒතර මේකෙන් නේවා මේ model එක save කරගත්තේ. ඒතකොට මේ save කරපු model එක ඔයාගේ local machine එකේ තියෙන 24 නම් ඒකෙන් load කරන්න බැරි වෙන්න පුළුවන්. එතකොට ඒ නිසා කරන්න පුළුවන් දේ තමයි අලුතෙන් මේ version එකම install කරන්න නම් මේ Colab එකේ තියෙන version මොනවද කියලා බලන්න ඕනේ. ඉතින් Python version එකක් තියෙන 3.7. ඒක නම් ඉතින් ලොකුවට අදාළ නැහැ. මේ අනිත් libraries අදාළයි. Right. After you have done that, you have this. You can see these three files are created in your Colab. You can like click that and download it. Then you can also create the web application using a Python library called Flask. Flask කියන Python library එකෙන් web application එකක් හදන්න පුළුවන්. What you can do is, let me just open up a created web API. So you can see this is a Flask API. So I have included scalar, pickle, heart attack, and the data pickle into this root folder. And then you can see in the app.py, I have created an endpoint. This is an API, right? Again, web application. 19 batch එකේ කට්ටියත් පොඩ්ඩි හරි අයිඩියා එකක් ඇතිනේ. API එකක් front end application එකක් කියන්නේ මොකක්ද? API එකක් කියන්නේ මොකක්දනේ? So API එකක් මේ හදලා තියෙන්නේ. එතකොට so in this API we have an endpoint called predict, where you can send a JSON body into this API. Like if I run it now, okay, before, so I told you that we need to have manage these versions. to easiest way to manage versions is in Python we can create something called computer එක ඇතුලේ පොඩි environment එකක් හදන්න පුළුවන් අර specific Python version එකකින් අර specific library version එකකින් පැත්තක හදලා තියන්න පුළුවන් මේ වැඩේට විතරක්. So you can see there's a file called environment. Here you can see all the libraries in that specific version can be installed into that environment and use that environment for your development work. So after creating an environment, you can activate that. So if you like go to this repository again and go to this last two, SPA is the application, it is an Angular application. API is what we are looking at now. If you go to there, you can, there are ways to, how to do that, how to install virtual environment and how to configure that. So you can go there and create a virtual environment and you can, yeah, this one, right? So I will change my terminal to PowerShell. PowerShell is much easier than command prompt, so I recommend you guys use that too. After activating the environment, you can see we get like this kind of a indication that we are now in the virtual environment. After that, you just have to run flask run. Unable to create process. Okay, having an issue. Maybe it's running on the background. Let me check. Sure, could be something else blocking the port maybe. Let me try to install the requirements again, then we can try to something, I guess is issue, it's an issue with Python, yeah. Yes, it's an issue with the Python. I will maybe have to delete that and start again, but it's actually, it should be straightforward method. How to create an environment as well. So we'll try to do that because then you will understand to do that as well. So basically, what you have to do is create virtual environment using this command. I will delete the commands terminals and create a new terminal in the PowerShell and then install this. So you can see I'm using Python version 3.7. Yeah, so it has been created. Now let's try that activation again, and then we'll try that, try to install the requirements again. Yeah, so while it is installing, let me show you that there is a way to deploy these things as well. If you scroll down there, you can, using Heroku Cloud, you can deploy these things to Heroku really easily. Very easily actually. Those are not very hard steps. I have given you these animations as well. You can go through this and deploy that as well. And then we have an Android application as well. What Android application does is basically send a request to that API that we created. So you can, if I go to the app component, so if you are familiar with React, you can do that in React as well. It doesn't matter. Yeah. Okay. So here you can see I am sending a request to this data that which I get from the front end application. Let me run that as well. So we are calling that API created in the Flask, and then we are getting some information based on this form. I have created a HTML form here to input data, and then you can send that data to the backend. Okay, this is taking time. Maybe I will show you the hosted version of these applications. Um, this requirement installation actually takes time because these libraries are really compressed libraries. Once they are downloaded, they have to expand them. Again, my libraries පොඩි libraries විදිහට compress කරලා තියෙන්නේ. ඊපස්සේ මෙතෙන්ට ආවට පස්සේ ඒවා expand වෙනවා. ඒකට තමයි ටිකක් වෙලා යන්නේ, right? And we'll try to run Flask run again. Yeah. Okay. Now we have created some, this is not actually a UI, but to make it a little bit beautiful, I have created this API as this way. And if Angular application is running, let me check that as well. Yeah, that is also running. We can go to there. So you can create a UI like this. Then you can enter the values, gender like this, male, female, chest pain type, and blood pressure, serum, fasting blood sugar, resting ECG, like so. You can enter these values, and then you can give you a prediction. Yeah, this person might be having an heart attack in the future, right? And I will change this variable like number of major vessels to 1. And if I click predict, don't worry, this person is out of risk. Yeah. So likewise, you can create web applications as well using that models that we have saved. I just want to demonstrate that aspect because otherwise, creating the model and training the model is not enough, right? You have to use that. මෙයා මේ ලොකු කෝඩ් ලියලා මෙයා train කරට දන්නේ use කරන්න බැරි නම් ඒකයි ඒ දෙක පෙන්නුවේ. එතකොට Flask වලින් API එක හදලා තියෙන්නේ. Angular වලින් තමයි front end එක හදලා තියෙන්නේ. Prediction service ඒකේ වලට පේන ඇති base URL එක අපි අර කියපු මෙන්න මේ URL එක. එතකොට ඒ URL එකේ predict කියන endpoint එකට තමයි අපි මේ request එක දාන්නේ with our data which we retrieved from the form, HTML form, and then get the response. And based on the response, we say this is positive variable is either true or false. Based on that variable in the component, we have shown that message out of risk or the might be having a heart attack, right? It is very simple. I mean, even the batch 19 guys can go through the code and understand what is happening there. And I have given some basic uh, guidance to how to set up and deploy this API and both API, and I have given that same instructions to the SPA application as well, which is the Angular application. So yeah, you can, Angular application is really easy. Yeah. That's it, guys. I hope you learned something new. And I saw there's a question in the chat that saying, are there any machine learning opportunities in the industry? Well, these days there are, because it is really hard to find those opportunities. But some companies like medium level and startup level companies are trying diving into this machine learning. It actually based on the business model of the company, right? If your company is having a requirement to do that, any company can do that. If even the games industry is now converting their solutions into machine learning because of the games as well. And other companies like CodeGen or other another startup companies like uh, new companies like John Keel's IT. They are trying to also trying to get recruitment from that machine learning expertise as well, as I have seen. But the opportunities are like there is a demand, but when you are trying to go to your um, first job as a software engineer, there is a demand nowadays. But if you really want to do this, it is also fine. I mean, you can. There's nothing as you cannot do. You can do that. What you have to do is just find the opportunities in this early stage as well. ඒ කියන්නේ දැන් ඉඳන් වගේ තියාගන්න එහෙම opportunities තියෙනවා නම් එතකොට ඔයාලට පුළුවන් ඒ කාලෙ වෙද්දී කොහොමත් ඉතින් දැන් තාම ඔයාලා තව අවුරුදු දැන් ෆස්ට් ඉයර්ස්ලා නම් අවුරුදු 3ක් විතර යන්නනේ. එතකොට අනිත් අයට අවුරුදු 2ක් විතර යන්න තියෙනවානේ. එතකොට ඒ කාලෙ වෙද්දී බලන්න ඔපචුනිටිස් හම්බෙලා තියෙවි. ඒ කාලෙ වෙද්දී කියන්නේ මේ මොකද මේ තියෙන තත්ත්වෙත් එක්ක නම් ටිකක් අමාරුයි. ඒ වුණාට ඒ කාලෙ වෙද්දී ලංකාවේ ටිකක් ප්‍රසිද්ධ වෙයි මැෂින් ලර්නින්. එතකොට ඔයාලට පුළුවන් වැඩිදුර ඒ ගැන දැන් කොහොමත් level 4 වලදී ඔයගොල්ලන්ට අහුවෙනවා research project එකක්. In level 4 as well, there also you can perform very well. You can publish some papers uh, related to machine learning, and then you can uh, you know then you can have a portfolio for that. So even in internships, people say that. So when I'm doing internships, intern recruitments, I see that some people have mentioned that machine learning is one of the expertise. But when if I ask how to increase the accuracy, or if like how to increase the performance of your model, or what is binary search tree, they actually struggle to answer. Without knowing this basic stuff, you don't mention those things in your course. If you are really passionate about this, you can learn this course. Actually, I have mentioned some courses as well in this repository, like this machine learning, Google machine learning crash course. This is actually a free course. You can it has like very good content, like 30 plus exercises, 25 lessons. And yeah, so if you are really interested, you can take this as well. And to take this course, you should know what is how to manipulate, like NumPy, pandas, and um, do many equations. Like, but it's not that hard. You just start at the process, you can understand and grow your knowledge. So I highly recommend this course. And if you are new to Python as well, there is a Python tutorial for beginners from YouTube. It is actually 10-hour course. And if you don't want to, there are machine learning studios. Like, you can use this Asia Machine Learning Studio and Percepti Labs. These are actually way of, visual way of doing machine learning. And somebody have asked me that higher studies in deep learning, so courses, I mean machine learning degree programs in University of Moratuwa, faculty as well, and in CSE department as well, and in Japur, and like so there are different state universities that you can try to go through and or rather get higher studies. But if not, you can go to a different university, um, and go out of the country as well. There are many opportunities, like actually. So first of all, try to come up with a good research for your level 4 project, and afterwards you can go through that project, and the experience that you gather from level 4 project is really helpful when you comes to the higher studies, right? So in the fields of data science, supervised learning, what I told you or rather showed you today is supervised learning, right? We had the target variable කියන එක තියෙන ඒවනේ බැලුවේ. But when it comes to unsupervised learning, it is totally different. Unsupervised learning doesn't have target variable. අර heart attack ද නැද්ද 0 ද 1 ද කියන column එකම සම්පූර්ණයෙන් නැති data sets තියෙනවා. එතකොට ඒ වගේ දෙයක් classify කරන්නේ කොහොමද? ඒ වගේ තමයි ඔය unsupervised learning, right? When you don't have a target variable, we call that unsupervised learning. So you have to understand that as well. If you are going to study deep learning, because deep learning is thoroughly or rather directly coupled with neural networks. So to understand neural networks, you have to understand this reinforcement learning and unsupervised learning as well. So the goal of this session today is to get you guys on board with the unsupervised learning, and try to demonstrate how we can train and test and predict and create web applications out of what we have created. Yeah, so okay, I will show you this if I can log in. Okay, let me try a different. Let me approve this quickly. Okay. Yeah, while looking into that, I will show you this perceptive labs as well. This is also another visual way to train machine learning models and visualize these things. You can use that as well. This is not actually cloud environment. This is running on your local machine. So it is also a Python package. So you can install that and you can do that as well. There are different ways, so you don't have to know the code also always. You can do that as well. So you can install this pip install Percepti Labs and then run it using Percepti Labs. Pip is like an npm for Python. A Python package manager is called as pip or other pip. npm වගේ එකක් තමයි Python වලට තියෙන එක තමයි pip කියලා කියන්නේ. හරි. Python දන්නේ තේින්න පුළුවන්. එයාට තමයි කිව්වේ. එතකොට ඔයගලන්ට මේක යූස් කරන්න පුළුවන් නැත්නම් මේකත් යූස් කරන්න පුළුවන්. මේකට නම් මට log වෙන්න බෑ වගේ. Okay. Yeah, having a hard time logging into that, guys, but this is also work. If you have a Microsoft account, you can log into that. Maybe I will show you the UI of that, because it is really easy. If you go to like images, you can create this kind of trees, like drag and drop modules. Okay, that is small, too small. Let me show this thing. So you can see, like, you can load the data in the first module, then you can train the module like so. You can drag and drop these modules into the workspace, and then you can train those data. There are tutorials for this in the YouTube. You can go through them and understand that if you hate writing code. Yeah, that is also one possibility to get started. So there are many other ways. I mean, if you are afraid of writing code, you can go through that. Yeah, and if you are a .NET developer, you can use ml.net as well for Visual Studio. Again, another library for .NET. I don't know about Java or other major programming languages. So if you are .NET, if you're into .NET, you can use ml.net and use machine learning in your local environment with Visual Studio. Yeah, so that's it, guys. Thank you. If you have any questions, do direct them to me. Okay, if you don't have questions, I guess we can wind up the session.
Seems like there are no questions.
Yeah.
Okay, yeah.
Yes.
Then let me conclude.
Okay.
We have come to the end of today's session, and I would like to take few seconds on record our hearty thanks to each and every one of you. First of all, a big thank and a heartfelt gratitude to our speaker, Mr. Nishan Vikramaratne. Obviously, it was an insightful session, and it is obvious that your experience and your knowledge caused to fulfill our participants' thirst for ML. I also extend my thanks to all the participants for the session. We think that today y'all could gain something valuable, and we really appreciate your passion towards machine learning. Thank you once again, and goodbye, all of you. Thank you, Aya.